All right, folks. Mr. Kuntz back again. We are going to do section 5-4 today. This is where we apply those trig functions. We're going to be doing, yes, the lovely word problems, the things you love so much. I'm going to give you some examples. I can't obviously give you every example of every kind of problem you could see because word problems could take any form. But I'm going to give you some different strategies and some ways of dealing with word problems that hopefully will help you through this section. So we're going to just look at a few different examples here and work our way through them. We're going to be using those same things we did in the last section where we're using the trig values, the basic trig ratios, and we're going to use them as soon as I get over to my notebook here. All right, so we've got a problem already ready for us to go. It says a 30-foot ladder leaning against the side of a house makes a 70-degree 5-minute angle with the ground. And part A asks us how far up the side of the house does the ladder reach? So what I do with these is generally I make a drawing first. They gave you one here, so you've kind of got a head start. Make sure you have things oriented properly. A 30-foot ladder leaning against the side of a house. So this is the ladder, so that's what's 30 feet, that side. And what we're looking at is going to be this. Let me get a color here. What we're looking at is this leaning against the side of the house. So we're forming this triangle, and this is a right triangle, so we can use a right triangle trig, all right? And it says it forms a 70-degree 5-minute angle. Now, even when they give me a drawing like this, I tend to make my own drawing again, just so I can get some things straight here and figure out exactly what the relationships are. So I'm going to do this. I'm going to make my own a little bit bigger triangle of this so I can look at it and I can label it a little bit differently. Again, a lot of times they give us things that are too small to work with. Oh, I don't want to do that. Let's go back here. I want that. I know this is 30 feet. I know this is the angle they've given me, and it is 70 degrees 5 minutes. So I'm not going to put that down as 70 degrees 5 minutes. I'm going to figure out what that is. 70 degrees 5 minutes means 70 degrees. Remember, we did this just in 5-1, I think it was. 70 degrees plus 5 over 60th degrees, right? 5 over 60. So what is 5 over 60? 5 divided by 60 is, and you will need your calculator during this unit, guys, so we are going to use it a decent amount. 83 repeating. So let's call it 0.083. 70 plus 0.083. Let me erase that right out, my full thought there. All right, so 70.083 degrees. And that's what I'm thinking of this here, 70.083 degrees. I tend to go out to at least 3 decimals. That way, it usually wants these to the nearest tenth, the final answer. So if I go 3 digits, I should be good in my final answer. So now, how do I find how far up the side of the house does the ladder reach? Well, the side of the house is this side of the triangle. So I'm looking for this side. So I want to label that right away. That's my X, my unknown, right? And what they're always going to do with these right triangle problems is they're going to give you 2 out of 3 pieces you need for any of the trig ratios. And in any trig ratio, you need the angle and you need 2 of the sides. So they'll generally give you either 2 sides where you got to find the angle, or they'll give you an angle and a side, and you got to find the other side. So in this case, what have they given us? This is where I go again, and I try to look at what did they give me? Because what I'm going to try to do is write a trig function to help me solve this with my unknown. So what is this in relation to my angle? This is the side opposite. This is the hypotenuse, and this, of course, is my angle. So what relates opposite, hypotenuse, and angle? Which trig ratio relates that? I'm going to go over here and start this problem because I'm going to write a trig equation. That's where I start. After I've figured out what my pieces are. And what relates opposite and hypotenuse, that would be sine. So I'm going to write the trig equation. And you could write it in general first. Sine of theta equals opposite over hypotenuse. And then fill in the blanks because you know what the angle is and you know what the hypotenuse is. So I can now say sine of 70.083 degrees is equal to the side opposite. I'm calling that X now, over my hypotenuse of 30 feet. So now I need sine of 70.083. So sine of 70.083 degrees is, oh, that's one thing I should mention, guys. always, always, always check your mode when you go into your calculator to do a sine, cosine, tangent, anything of these trig functions. If you're going into your calculator to use it, always check your mode and make sure that you are in the appropriate one. In this case, degrees, right? If we're doing radians, we'd use radians. Right now we're using degrees. So I made sure it was in degrees, and I find that that is equal to 0.9401, I'll call it 019, rounding it to three digits past that, three significant digits past that. So we could even, we'll leave it at that. And that's equal to x over 30. So now I want to multiply that 0.94019 times 30, right? Because I'm going to multiply both sides by 30. And that tells me that when I multiply this and this by 30, this side becomes x, this side becomes 28.2. Right? And now we have to give our final answer. We've got x. Now, what does that mean in terms of our final answer? The answer would then be 28.2 feet. I want you to always be conscious of this. When you're done with a problem, always say, all right, now what do I put in the answer blank? In this case, it's asking how far, so we have to use units. This is feet, right? They gave us units to work with. We have to use units. So it's 28.2 feet that it rises up the side of the house, right? So we've got part A done. So now let's look at part B. What do I do for that one? Well, let's look at it. Part B says, what is the horizontal distance between the bottom of the ladder and the house? So now we're talking about this side is what we need. And this side, I'll call it Y, just to call it a different variable. This is our adjacent side, right? So now we were given the hypotenuse, adjacent, and the angle. And we have to find, I should say we're given the hypotenuse and the angle, and we have to find the adjacent side. So what relates adjacent, hypotenuse, and the angle? Well, that would be cosine, because we know cosine theta is equal to the adjacent side over hypotenuse. And for us, that means cosine of 70.083 degrees is equal to the adjacent side we don't know, we're calling y, over 30. So now I need 30 times the cosine of this. So let's just put that all in the calculator in one step. 30 cosine of 70.083 degrees. Again, knowing my mode is in the correct degree mode. And I get, for this one, y is equal to 10.2197. So up here, I would say it is 10.22, well, we could go 10.2 feet. I guess if we're going to nearest 10th, then I'd say 10.2. Again, I have to make sure I use units. So that would be feet. And that would finish this problem. All right. So that doesn't look like a 10. All right, a little bit better. All right, so we have that. Let's go to the next one. Now we're going to pull in some of your geometry. Okay. Geometry, the apothem of a regular polygon is the measure of a line segment from the center of the polygon to the midpoint of one of its sides. That's this part right here, guys, from this center to the midpoint of the side of this polygon, the polygon being a hexagon here, right? So this length, whoops, I messed it up, is the apothem. All right, so let's see. The apothem of a regular hexagon is 2.6 centimeters, okay? Find the radius of the circle circumscribed about the hexagon to the nearest tenth. Okay, so I need to do some work here. I'm gonna redraw this like I said I always tend to. I'm gonna make my own hexagon over here a little bit bigger for me to work with. Whoops, I did not want to do that. All right, I'm gonna move this. Okay, there we go. Move this over here. And now I'm going to start redrawing this a little bit. All right, I'm going to do this. I know my apothem is from the center to the side. And they told me that was 2.6 centimeters. So I know this is 2.6 centimeters. right? And they want the radius of the circle circumscribed about this. All right, so let me do circle centered about here. Oh, that looks pretty close. Go here, there. All right, so they want the radius of the circle. All right, if I look at the radius of the circle and I think about what that means, the apothem goes from the center here to the middle of the side of the polygon. The radius is this thing that's going to go, I wanted to draw that as a line. Hold on one second. Do this. It's going to go from here to there, but more importantly, it's going to keep going all the way across to there, right? So I don't have a way of finding this diameter, but I can use this triangle, and I can do this, complete this triangle, and more importantly, look at this piece. This is a right triangle that we can use, because if I can find, well, I should have done that the other way. Hold on one second, guys. Let me make this a little bit easier to see. All right, that's what I wanted. All right, so we know this is 2.6 centimeters, this apothem. If we complete this right triangle, this would be the radius, would it not? So I am going to think about this larger one that I drew and erased, just because this is a regular polygon. If this is a regular polygon, these are all radii of that circumscribed circle, right? And these are equal. So each of these angles is equivalent, and we have 6 of them, right? So each of these is 60 degrees, which makes this angle 30 degrees. So again, now I'm looking for this radius, right? And it's supposed to be an R. I have this side, which in relation to this angle is the adjacent side, and I have the angle. So how can I find this radius? Well, I know that, again, this side is my adjacent side. I'm looking for my radius, and I've got my angle. What relates, this is my hypotenuse, right? That's what my radius is. So what relates hypotenuse, adjacent, and the angle? That is going to be cosine. So I'm trying to write always a trigonometric ratio, a trigonometric equation. So cosine of 30 degrees is going to equal that adjacent side of 2.6 centimeters over the hypotenuse, which is the radius we're looking for. So now, I'm going to use a little trick here that's going to come up a lot this year. If you have some value A equal to B over C, then you can actually switch these, because every time if I multiply by C and then divide by A, it essentially switches these two. So this implies this. So what I can do here is say that the radius is equal to 2.6 centimeters divided by cosine 30 degrees. Or you could just go in the slow way and multiply each side by R, then divide by cosine 30, but you're going to get the same thing. You're going to get to this point. All right, so our radius is going to be what? Well, let's find out. Let's do 2.6 divided by, again, being careful of our mode. We want to be in degree mode and do cosine of 30 degrees. And we should end up with, let's see, that would be 3.0022. 3.0022. And so we could give an answer as, say, 3 centimeters to the nearest 10th. And that would do it. All right, again, we could go further in this type of problem. You're going to be asking homework, I think, to find like the area of this. Well, you can find of these, one of these 6 pieces, and you can just do that by finding the area of one of these smaller pieces, right? Using 1/2 base times height, do that kind of stuff. There's a lot of different things you can build out of the same construction, so be aware of that. Let's keep moving though, because I want to do one more problem before we're done. Because this one, over years, there's a few different ways of doing this, but I found one way that seems to work for a lot of people. And so I'm going to go through it that way for this problem. Person standing 100 feet from the bottom of a cliff notices a tower on top of the cliff. That is this thing over here. That is our tower. All right. The angle of elevation to the top of the cliff. When we talk about angle of elevation, and this is going to become important, angle of elevation. Angle of elevation is from where you're standing. If you're looking up, that would be, say, this guy, he's saying to the top of the cliff. This is the angle of elevation from level looking up. So that is the angle of elevation. If for some reason they wanted to, they could give you the, well, let's not even get into it. The angle of no, let's just stay away from it. Angle of elevation we'll deal with right now. We'll deal with the other one coming up. All right, so for the angle of elevation, they told us it's 30 degrees. Angle of elevation to the top of the tower is 58 degrees. So again, from horizontal, we look at our line of sight to the top of that, and that's the angle of elevation. All right, so we have these two angles. It says how tall is the tower? So what we're looking for, and this is what I always do, is mark these things up a little bit. We're looking for this length, right? That height to the top of the tower. Let's not even call it X. Let's call it H. There's a reason for that. All right. Let's call this overall thing H. All right. That's that whole height. Now, think of what we have here. How are we going to work with this? Again, what I want you to see is we have, and my drawing is going to be slightly off here, just trying to follow that. We have this triangle, the big triangle. If I redraw that triangle, and I'll just do so badly here, we know that this is 58 degrees. We're looking for H, and we know this is 100 feet, right? At the same time, we know something else. That we have this triangle, and if we call this height X, we can draw that triangle. So if we have this triangle, again, a little bit out of scale, that's 100 feet. This is X. And we've got an angle of 30 degrees in this one. So how are we going to find this overall height? What can we do here? Well, think of what H is. H has X as part of it, doesn't it? Yes. And what is that? If we think of H, it's X is the height of the cliff itself. And then we have to add to it the height of the tower, right? Well, we want to know how tall is the tower. So when we look at H, what we're really looking for is that piece of this, right? When I talk about it, what we're looking for is how tall is the tower. This is the thing we're looking for. Yes, this is the tower height, which is going to be composed of two pieces. It's going to have the height of the tower and the height of the cliff. The reason I bring this up is because I want you to see is I have in each of these triangles the ability to find H and the ability to find X. So if I take what H is minus X, I would get what's left as the tower. Everyone follow that? So I can draw these two triangles and I can solve them. This one here, what do we know? We are looking at, let me go back and get the right color here. We are looking at, we got an angle, we got the side adjacent, we're looking for the side opposite. What relates opposite, adjacent, and the angle? That would be tangent. So I could write tangent of 58 degrees equals H over 100. Opposite over adjacent. And that makes H equal to 100 tangent 58 degrees, which is 160.03. Actually, I'll say 0.033 feet. And we've got the overall height. That's the height from down at the bottom of the beach all the way up to the top of the tower. So we've got one height. Now let's look at this one. With the same one, I can do the same idea. Tangent 30 degrees is going to equal the side opposite, which we're calling x over the side adjacent, which is 100. So x would equal 100 tangent 30 degrees. And we do 100 tangent 30 degrees. We get 57.735. So that's 57.735 feet. So how do we know how tall the tower is? Well, we just said, this is the height of the tower and the beach, the dune. This is the height of the dune. So take one from the other, we will get the tower. So the height of the tower, oh, I didn't change color, did I? There we go. Height of the tower is equal to the 160.033 minus the 57.735. So what does that equal? That gives us 160.033 minus 57.735, and that would be 102.298. So we could say our answer would be to the nearest tenth, 102. Let me make that actually look nice. So our final answer would be 102.3, again, in units, feet. And we would be set. All right, again, just to go back over that strategy, if you're given something, these two angles, later on, I know for some of you may still remember last year or 2 years ago when you did this, you might have done law of sines, law of cosines. That's when you don't have a right triangle. We have a nice right triangle right here. So we're going to use that every chance we get. When we see a right triangle, it makes life easy. And that's why we can use that right triangle in both of these triangles to solve for the pieces that we have of each triangle. That gives us the relationship of just this tower. All right, and that's it, guys. You're going to have, again, a variety of problems. I can only give you some of them, and I did. I gave you a few different strategies, a few different ways of approaching these. So get to work on the homework and ask questions tomorrow when you get stuck. Make sure you take notes on that, of which ones are giving you difficulty. All right, have a wonderful day, and I will see you tomorrow. All right.